Hello, everybody, and welcome to this session titled Immersive Technology, Education as a Portal to Virtual Worlds. It's a pleasure to speak with you all today. This event's been brought to you by the Digital Education Futures Initiative, DEFI, at Hughes Hall, Cambridge. My name is Louis Major. I'm a Senior Research Associate at the Faculty of Education in Cambridge, Principal Researcher for DEFI, and I'll be moderating today's session. So this is the first session of our new DEFI Digital Learning series. These are going to take different formats and will generally be held on the fourth Thursday of every month. Please do visit our events page. The link's on the screen and will shortly be posted in the chat for more information and details of how to sign up. And a particular thank you to the Arm School programme for their support of this exciting series. So dialogue is central to the DEFI mission. We hope that networking will take place after and between each session. So now you should be having an option on the screen. If you could let us know if you're happy for your contact details to be shared in the attendee list to be distributed after today's programme, then please just do click on there now. And I'll just give you a couple of seconds to do that. So today we've lined up 3 presentations and an exciting panel discussion. Please do use the question and answer button to submit questions for our panelists, and the chat facility is also available to support said networking and open discussion. We understand that the session was listed in Zoom as running for around 1 hour. The presentations will be done in that time, but we may run until 18:15 UK time, 6:15, depending on the number of questions received. And it's my great pleasure to introduce the 3 panelists we have today. First, Dr. Sim Baweja is a physical therapist by trade, a neurophysiologist by training, and Sim himself describes himself as a mad scientist by choice. He is an associate professor of physical therapy at San Diego State University. There he directs the Neuromechanics and Neuroplasticity Lab, state-of-the-art facility that uses immersive technology to simulate different environments. Sim is also the university's Instructional Technology Faculty Fellow for Immersive Learning and Artificial Intelligence. Dr. Thomas Bohné is a founder and head of the Cyber-Human Lab at the University of Cambridge's Department of Engineering. His team focuses on how digital technologies can augment human abilities. By using primarily an experimental approach, they aim to understand and optimize the performance of hybrid human technology systems in industrial context. He and his team have received many accolades, including the Institute for Manufacturing's Research Excellence Award in 2019 and the Best Paper Award of the 2020 IEEE Conference on Human Machine Systems. And our third speaker, Bruno Caballero, is a co-founder and director at Yaltic, a virtual reality learning company based in London and Mexico City. Bruno has a Bachelor of Sciences in Physics and has worked for IBM in Mexico and Germany. And after switching career path and working for 6 years for Audi in Germany, Bruno has earned an MBA degree from the Cambridge Judge Business School, and he is an alumnus of Hughes Hall. So thank you. Please enjoy the session and do spread the word. Also, as you can see, the Twitter handle here, our email address if you have any queries after. And as I mentioned earlier, please do sign up for further information. And on that note, I'm going to stop sharing my screen and pass over to our first speaker, Dr. Sim Baweja.
Thank you, Louis. Thank you so much. I'm going to share my screen and then let's get it rolling. I have been given, I guess all of us have been given 15 minutes to talk about something we love. So I'm going to put myself on a timer. That way I'm fair to the rest of our speakers. And I titled my talk, The Unorthodox Professor, so that we could at least start thinking about how we're going to be teaching the future. And I say that very consciously to all of you, because when we started doing this work around 7 to 8 years ago, bringing it into mainstream academia, teaching using immersive technology, I got heckled at a couple keynote lectures that I gave. So I want to give you a good insight into how we do work and what we do, not discounting, the current traditional pedagogy that we already use, right? So I'll talk a little more about that. But thanks to Louis for the introduction and a quick brief reintro on what I do. As a physical therapist over here, I teach neurophysiology. That's my research training. I do work with a lot of substance abuse professors, and we do a lot of research on how substance abuse affects movement and motor control. I'm specifically interested in driving, so I do a lot of driving simulations in my laboratory. This is my lab where we're sitting right now, and we can talk more about that. I've set up the neuromechanics and neuroplasticity lab. This is where we are. I'm the faculty fellow for immersive learning and artificial intelligence for the campus right now. I also served in that capacity for the university system. That's 23 campuses across California for a couple of years earlier. And I've given my email and Twitter handle to you so that we could get in touch, keep in touch, and maybe actually expand the work that we're doing beyond the realms of our own small caves that we live in. That's the beauty of this work that we're doing. So I encourage you to keep in touch, and let's collaborate and work. And I'd like to start what I'm going to tell you by showing you this photograph of the 5th largest glacier in North America, up in British Columbia. It's called the Salmon Glacier. It is 2 miles wide. The photograph doesn't do justice to the scale of what you're looking at. It's 2 miles wide and 14 miles deep into the horizon, a photograph I took a couple of years ago when I was there. And the epiphany I had while I was there was that we're only limited by our imagination. And I say that because who would have imagined that you would be sitting wherever you are around the world, with me here in California and you there in England. And I believe somebody in the chat wrote that they were tuning in from Greece and other places. So the beauty of just technology in general, but then it immerses you into bringing you into this space where we all can collaborate, connect, and talk to each other, irrespective of where we are, even in the middle of a pandemic, makes it beautiful. And so I want to put it out there that imagine, and then we can actually make it happen. So that's, we are limited by just imagination. Going back to the heckling on a keynote once upon a time, I'd like to show this to, describe the differences in perspective, but remember that we're still talking about the same things. This is the campfire at a campsite where I was a long time ago. And I took this photograph from a drone top down and from my cell phone bottom up, to show you that even though it might seem we're talking about different things, we are not actually. We're talking about how we can better education in general. And so not discounting our pedagogy that we've already been up to, we will be talking about how we can enhance, extend, make it immersive, and make it better, right? Something that I would encourage you to do is go read this book. It actually sparked a lot of thought and discussion within myself and my colleagues that I work with. And this is a book that talks about 21st century skills, rethinking how our students learn. Because early on during my professor days, assistant professor days, when I was a junior faculty member, my teaching evaluations were reflective of the old school methodology that we were teaching with. And that sort of looks like this, and your students think you're a dinosaur who wants them to sit down, listen to me, and take notes. But how do you flip that classroom? How do you make it engaging for them? And what motivates me as a professor is flipping the narrative and having a discussion with my classroom and teaching them the way I would have liked to have been taught. So that's how I inform my classroom. And so taking that forward, this was okay in our times. This is what it looked like back in the good old days when people would sit down and do their reading. But somehow there are still colleagues of mine, and I also struggled with this half a decade ago, that it wasn't okay to see our students doing exactly the same thing with technology of their generation. So what stemmed from all of that, and not just me, the industry in general, was how do we actually bring this and use this to our benefit, that we actually use technology to enhance the way our students are engaging in their academic or other activities, co-curricular in general. So now I can be Dr. Dinosaur, but I can still be up to the par with their technology and use the tech to my advantage to engage with my students. And I'll give you a few examples of how we do that. So at San Diego State, before I go any further, especially in terms of education, in research realms, we have research grants, we fund our labs, we keep moving. But when it comes to doing large scale implementation in terms of taking it into every classroom or specific classrooms for specific courses, you have to have forward thinking, supportive leadership from the university that supports the endeavor and makes it possible. So at San Diego State, our endeavor is called VITAL. VITAL stands for Virtual Immersive Teaching and Learning, where the Instructional Technology Services has set up specific classrooms. Now, most of the classrooms are actually equipped with technology from where you can broadcast internationally, within the class, across classrooms, and you can plug in any device you feel like to teach and show your students what's going on across several disciplines. In fact, I think it was 4 years ago when we achieved 100% rate in every college. So we had a course, at least one course in every college across the campus from a 100 level, that would be an entry level undergraduate degree course, to an 800 level, that would be a doctoral level course, where we were using immersive technology and technology in general to teach our courses and enhance pedagogical techniques. And when we think about the use of immersive tech, typically people think about it in terms of it being just virtual reality. And I will define for you what I mean by immersive technology, what I mean by extended reality or experiential reality. But it stems from this very old idea of if you tell your students, they might forget if you just talk to them one directional. If you show them some and you draw something on the blackboard or the whiteboard, whatever you're writing on, they might remember. And I hope you're able to relate with this. But if you engage them with the content, they will understand. They will have the epiphany, the aha moment more often than not. And that's been the struggle in translating some difficult bottleneck courses. So what's new? Why now? Why do we care about it now? Why is this a big deal? In fact, I think this is a very timely discussion, because even up until 7 years ago, when I started dabbling in this in my classrooms, people thought it was a fad. We didn't think that this was going to last this long. Yeah, so we pioneered it, we were going to use it, and then who knew whether the industry was going to support it or not? And over the series of the conversations that are going to happen, you will see that now is the time, because we've been talking about this for over 100 years. These are photographs of what immersive tech looked like over 100 years ago. And it was described in 1965 by Ivan Sutherland, who's considered the father of modern virtual reality, that the ultimate display would be a room within which a computer can control the existence of matter. With appropriate programming, such display could literally be the wonderland in which Alice walked. And it is absolutely true. In fact, now you can do it using a cell phone, and you can do it on a laptop. You can do it on your screen. I can be creating environments over here that you could see wherever you're sitting in the world. So from 1965 on, we've come a very long way. And this is what today's immersive technology looks like. To set the stage for the rest of the speakers as well, that this is the continuum of virtuality that was proposed in 1994, where on the left you have the real environment, and then you have augmented reality, where you can take your current reality and augment it and superimpose a couple objects on top of it. From there, you have augmented virtuality, where you can project real objects in a controlled virtual world. So you can flip that, versus you can be in a completely digital environment by putting on a virtual reality headset, and that's called virtual reality. And especially when you look at VR, you can do anything. You could be standing on top of the moon, you could be standing inside the heart, and then be a blood vessel, be a blood cell that travels through the blood vessel and see how blood travels through the body. So here is the beauty of VR or immersive technology in general. Is with VR, you can go anywhere. You can be that red blood cell, or you could be an astronaut, and you could be anywhere you wanted to. With augmented reality, it will bring anything to you. It makes your life easier. You could use it. Google Translate, for example, is the simplest thing you can use on your cell phone, and it will help you translate things when you're in a foreign country. And it shows you, for example, on the right, I've shown you that if you were reading a foreign sign letter in a foreign language, you could actually translate it with Google Translate with your cell phone. Something as simple as that is an example of augmented reality. So I want you to break the mold of immersive technology being VR, but being more than just virtual reality. What mixed reality does, it is combines the virtual and physical environment. So over here on the left panel, we have an engineer who's wearing a HoloLens and is working on a motorcycle, trying to design what the motorcycle's parts should look like. On the right side, we have somebody who's seeing keys dropping on a real keyboard so that they could play a song. And with mixed reality, the person can actually see what the design should look like before they actually go and fabricate and design more things on it. So I'm sticking very specifically to education, but if we have the time, we can talk more about research. So moving on, what I'd like to propose to you is Baweja's correction of the virtuality continuum circa 21 is that you can engage the real world to the virtual world. And that's the continuum we know of, but it is highly visual. But over the period of time with the research that at least I've been doing, and I believe that we'll be hearing from the other panelists today, is you can engage the other senses beyond just vision. You can engage touch, haptics, audio, besides just visual, and feel the virtual environment as well, and not just virtual, the augmented environment as well. And I'm throwing these out so that we have time to discuss this today as a panel, as a group, as all of us will talk about this further. So, question you have been waiting for is how do we use it? Here's an example. Here's an iPad that you can use. I was going to show this to you real time, but for some reason, I'm unable to have my iPad talk to my laptop right now. But on the back end, there is a skeleton. And this is exactly how I teach anatomy, because the beauty is the screen that you see on the iPad is the screen that all my students see, because I'm sharing screen, and that's what they see on their laptops. So instead of me asking you to stare at the brain when I'm pointing it from here, you get to see my first person perspective of what I want to see on the brain if we're sharing it using virtual reality or with the augmented reality in this case. These apps are available for free. These apps are also available on a paid subscription, and there are outstanding applications out there from publishers like Elsevier that can be used to teach anatomy, and I use it very heavily in my classrooms. Here is another example where on the table you see that there is no cadaver, but using an iPad or a cell phone, you can project a hologram, if I may, of a cadaver and do cadaveric dissection and train medical students how to not just in anatomy, but in surgery and post-surgical methodologies as well. Here is a real human being sitting in a green room who is a paid actor. We went to Microsoft and took photographs of a paid actor doing a few things that we would wanted them to describe in terms of clinical outcomes. And then this was a pet project from our IT department over here. And this is a hologram of the same patient whose vitals are visible to you when you wear a HoloLens. And our nursing students can interact with this hologram to understand what's happening and see what anaphylactic shock looks like. Other examples look like, and I'm running out of time over here. This is a 100 level class. Back in the day, this is how we used to teach phases of the moon. You put a foam ball on a popsicle stick and have them move through a lamp in a dark room. And now what you can do is you can go into a virtual reality environment and plug and play and develop your own solar system, if you may. I've tried it. It's a lot of fun. And then you can teach them the phases of the moon. You can go one step better, and you can actually see not just the phases of the moon, not just the solar eclipse or a lunar eclipse, but you can ask the student the most difficult question: what does the Earth look like during the third quarter of the month? And they can walk away from the Earth towards the moon, turn around and look at the Earth and actually see for themselves, immerse themselves and know what it looks like. So it's not an You don't have to force them to imagine. Rather, you can show them what it looks like, and they would understand it straight up. With that, I will stop talking, and hopefully the future doesn't look like this, because it beats the purpose of education, and there are better ways of immersing our students in a classroom. And I had a small slide for Louis over here, because we disagree on what our favorite red color is. I believe this is the red color, Louis, that you should be looking for in future. Thank you very much for your attention.
Thank you very much, Sim. Thank you for stopping sharing the slides just then. That was a really interesting talk, and it was fantastic, sets a fantastic basis for our other panelists. So now I'm going to pass over to Dr. Thomas Bohné from the engineering lab here in Cambridge.
Thank you, Louis. Hi, everyone. So I'm Thomas, and I'm leading a relatively new lab in Cambridge called the Cyber Human Lab. And we are quite an interdisciplinary team. So I bring together engineers, computer scientists, psychologists, and we are broadly interested in how we can use a range of digital technologies to augment human abilities and improve human performance, primarily in industrial contexts. We have three very broad research themes we are interested in. One is around the challenge of digitizing everything. From our point of view, the status quo, at least in industry, is that a lot of companies are starting to digitize their infrastructure. For us, the interesting and real engineering challenge is how do we actually digitize processes and people and integrate them into these virtual worlds. A second challenge we are interested in is the human VR-AR interaction or interface. It's interesting that Sim already mentioned this, so I don't want to go too deeply into it, but I completely agree and empathize with this point. Right now, I think the interaction between humans and AR/VR devices is pretty, I think it works pretty well, but it's still relatively basic. And there's a lot of potential to integrate other human senses into this whole immersive experience. And then, of course, the third challenge, which for us is actually the most interesting one, is this whole question of cyber-physical impact. Because at least in an industrial setting, this technology is just a means to an end. And the end is actually to create a real impact with this technology and perhaps change human behavior or some other positive impact in the world. And the question is, of course, is that possible, and how can that be achieved? And that's something we are really interested in researching, and if possible, of course, help to engineer. We are working very closely with industry. Also, we are completely independent, of course, in the research we are doing. But for us, it's a very, very interesting context in which we can do research, because the problems we are dealing with, they're all real problems being faced by actual people in real contexts. And so for us, it's really fascinating to work very closely with a range of companies on different topics, whether that's proof of concept or pilots or actually experiments. And indeed, experiments are one of the things we have specialized in the last couple of years. One of the big weaknesses we see in research on this topic is that we see a lot of studies, but not a lot of studies that have a lot of participants. So from a statistical point of view, a lot of these studies seem quite underpowered, and there's a lot of potential to do better research. And we're also very much at the beginning of doing this, but we see a lot of potential to do much more impactful research to understand some of the potential of these technologies. We are very much grounded in the reality of industry, as I already mentioned, but in a wider context, we also are motivated by what is at least perceived in some parts of the world, particularly in industrial contexts, as real skills gaps in industry. And so a big challenge for industry, and I just have thrown some quotes from the UK and Germany, with both countries are most familiar, here on this slide, because a lot of companies are actually struggling with skills. So they either can't recruit the skills they want, or the people they have the wrong skills. And then the question is, how can companies reskill or upskill some of their employees? And that, of course, is a huge challenge, because the scale at which this has to happen is very significant. And so, of course, one of the interesting ways of how companies can help upskilling or reskilling some of their employees is to use a technology such as virtual reality. And so some of the use cases we have already seen in the last couple of years are, for example, Walmart ordering 17,000 headsets just to upskill some of their employees on some very specific use cases. So one use case that is often mentioned in the press is Black Friday events. So these very extreme events where employees experience a lot of stress, which are very difficult to simulate in a real environment. And of course, virtual reality makes that possible. So you can throw an employee in that situation and potentially provide him or her with some training experience. Another use case, which is really interesting and quite applicable to a range of use cases, are dangerous or very expensive situations. So imagine an oil rig, as the example here on the right side. An oil rig is a very expensive asset, very difficult to access. How do you actually train people for these situations or for situations that are very rare and only happen very rarely? And that again is a prime use case for virtual reality technology in that it can simulate these very expensive, difficult to access, dangerous situations. But of course, in an industrial context, it's also big business. So for example, take a company such as Siemens, which is a global industrial company. They spend about 500 million euros a year just on training and development. And so I don't want to go through all the numbers here, but I think one number that is interesting is that on a per employee basis, this company spends about 700 euros or so per year, and that excludes travel costs. So it's actually a significant expense for companies keen to train their employees. And that, of course, offers opportunities to do that training better, but also potentially cheaper. Now, moving a little bit to what I'm actually doing with my team, and one of the projects I wanted to share with you today is around the idea of perception engineering learning with virtual reality. What we're doing in this project is we're taking a real industrial task. In this case, it's the assembly of an industrial product. And we are interested in whether we can actually create training environments that are better than any other training environment in which people can be trained to learn how to assemble this product. And in industry, surprisingly enough, the current baseline for these kind of trainings is the very humble paper manual. So believe it or not, a lot of apprentices and people in industry learn how to do this based on a simple paper manual. And of course, that's a low-hanging fruit to then think about, could this be done much more efficiently and perhaps even better with other technologies? And virtual reality comes in mind. But for us, what is really interesting is to use this as an example to think about how can we actually optimally design a virtual reality environment such that it actually produces the best learning outcome at the end of this exercise. And so what we did is we used this as an example, and then we set up a basic experiment. So we had, as a baseline, we had the paper manual as a training, and then we had a basic virtual reality environment, and then we used what we call a perception engineered virtual reality environment. In that perception engineered virtual environment, we actually included a range of ideas we had for instruction principles and design elements to really see how can we optimize potentially this training experience. And so you see on the left side here the real task, and then we modeled this in virtual reality, and we put in all sorts of tricks of the trade to think about instruction principles and design elements that could potentially aid the learning process. So whether that's some form of persona effect or modeling examples or attention cues and fading effects, we were kind of thinking very broadly about what could be done to enhance kind of that training experience in some form or shape. And what is really interesting is that we actually managed to significantly improve learning outcomes, which we measured as, for example, the time to completion. So how fast were people then after the training in actually assembling the real product? And so, for example, compared to a paper manual, people who trained in virtual reality in the optimized virtual environment, they were 55% faster than the people who were training with a paper manual. And even more interestingly, the people who were using a paper manual, they made more than 300 times more mistakes compared to the group that was trained in virtual reality. And of course, these are very early results, and we need to do a lot more research, both longitudinally, but also with other tasks and other things, of course. But for us, this is already a very encouraging beginning to think about the potential virtual reality has for training. And so that was the impulse, the ideas I want to share with you today. I'm happy to take any questions and then pass on to the next speaker. Thank you so much.
Thank you, Thomas. Just a quick question from me while Bruno loads his slides. What's next for the lab? What are you thinking is the next big project that you're going to be working on?
So yeah, thank you, Louis. We have a couple of projects currently going on. Of course, we have been impacted quite a bit by COVID-19 because it has been really, really difficult in the last 18 months or so to do physical experiments. We are currently running a longitudinal study in which we really want to understand the longitudinal effects, because one of the criticisms, and I think it's a fair criticism, is in some of these contexts, it's possible to imagine some form of novelty effects. So people, of course, being exposed to virtual reality for the very first time, they're super excited by this. And then particularly when we look into human factors and things such as, did you enjoy this experience and so on and so forth, the scores tend to be very, very high. But the question is that a sustainable thing? And does it maybe disappear after some time? And how does virtual reality compare to other training media over time? And so that's something we are currently working on.
Well, thanks very much. And now I'll pass over to Bruno.
Thank you very much indeed. My name is Bruno. I'm co-founder of Yeltic, and I'm in charge of operations. So what I have for you today is a little bit about examples and projects that we've done in the industry. I share a lot of the opinions from Thomas and Sim, because we're practitioners, and we find a lot of the problems and solutions that we heard today. We develop educational solutions based on experiential learning using immersive technologies and gamification dynamics. We've been working with virtual reality for over 10 years. We are based in Cambridge and in Mexico City. We are very agile, and one of the things that we find in the projects that we do is that the requirements change a lot. So at the beginning, the client is not very sure about how to approach the educational problem that they have. And so we continuously develop the models and the project and the environments and everything that goes around. So agile methodologies help a lot for dealing with this complexity. We collaborate with universities. We have 5 working relationships with universities because it is very interesting for us that we define new ways of doing things, and also that we measure the results in very, very good ways. We have over 30 customers and clients and organizations with whom we have been working, and those are typically very large organizations, NGOs, and the verticals of manufacturing, technology, financial services, and armed forces, where we work also a lot, and government. And without further ado, I'm going to talk about implementations and things that we do on a daily basis. The first example that I have for you is about a painting manufacturer, and the problem that we were seeing there to resolve was how to upskill painting technicians from remote areas. And the company had quite a good interest on helping people in remote areas to be better painters, basically, and so that they don't have to migrate to other areas, to other cities or countries, and they can really learn how to paint. The difficulty was to bring enough technicians with enough knowledge to those remote areas, and what we did for them was to create this training where they learn the basics, so the right techniques, the best practices for the painting of cars. It was very interesting to see how to really take the brain from one very good technician and the skills that they have, and to put it inside a virtual reality training. That was quite tricky, but working with the experts, with the expert technicians, it was possible to create this training that really reproduced in a very nice way the feeling of having the painting equipment and using it there. We provided the whole solution, a truck with different VR headsets, so that they bring it to different places, and it's been quite good. A great productivity increase, but especially the results with the students in the rural areas has been fantastic, and very happy about doing this project for this company. The second example that I have for you is a very large beer brewer, and it's quite a pleasure to work with a beer brewer, and very fun as well. The thing and the problem that we were meant to solve was how to reduce maintenance accidents due to human error. And on that, we were talking about reskilling, upskilling, but also the fact that there are sometimes people and technicians that have been doing the job for many years. And they are very, very good, and they're experts in whatever they do. But sometimes they lack the understanding about how to keep themselves safe. And sometimes they ignore the rules. And so how the approach for this was very, very interesting, how to persuade people of following the rules, basically. And what we did is to really set up the whole environment, trying to stop not to stop the production line, so that they have the equipment available for training, and also to really expose them to the consequences of not following the instructions and the best practices for their safety. Persuasion was very, very important, and this gamification too helped a lot to create a very positive competition among technicians. We had really good success with this project, and the maintenance and the learning for the maintenance was performed quicker, a lot better than going to the manuals, because really they had one of the methods that they did is that they gave the manual to the technicians, and the poor technician was reading hundreds of pages, and that was very difficult. Classroom was not so much the focus, and what they were doing is that the younger technicians were following older technicians or more experienced technicians for this. So that's another example of how to persuade people in following safety guidelines. One of the largest projects that we've done has to do with the prevention of school bullying, and this is a very different project, nothing to do with industry. But the whole idea here is to create a video game, where people 13 to 18 they develop social emotional skills, and to cope with bullying situations, and to really know what to do if they're being victims of bullying, or they're witnessing bullying situations at school and outside. Also, what to do to protect themselves with cyberbullying in a safe and controlled environment. And it's a really good way of allowing people to make mistakes in a very safe and controlled environment. We've been working with Facebook with this, and they have been developing this with us, and we've brought this training to 80,000 students in Mexico and Colombia. It has been a fantastic experience, especially when the younger students have learned a lot about the things that older students know a little bit better about safety, about how to protect themselves in social networks. So it's quite a nice project, and very, very useful for younger teenagers. With the world's largest bread maker, we did a different thing. This is a blended solution where there was this training for the drivers. They have their own distribution network, And what we produced was the course on tablets that are delivered in classrooms, but also virtual reality headsets for the practice. So the drivers can use the virtual reality to be exposed to difficult situations and they can practice instead of taking a car and really going outside, which is what they used to do. That helped a lot for them because we were able to reduce accidents in a 30%. That was a really good thing. So the amount of accidents in the 6 months after the training, we reduced that in 30%. And the trainers, both the trainers and the students were very happy with the solution because it gave them the tools that they needed for transmitting the content of the course effectively. Another example of the usage of VR, and this is not so much about learning, or in a way it is, but how we help the Navy on how to use virtual reality as an exposure therapy tool. For this is a completely different thing, but we created the evaluation and treatment protocols using CBT. The VR solution is just a way of exposing the soldiers to these traumatic situations, and from there they follow the protocols to help them. This is now daily used in several hospitals and clinics throughout Mexico. We increased the reliability of patient diagnosis, which was lacking, and so that was a very good result. We reduced the number required of therapy sessions, and really in a very significant way, and the effectivity of the training. And to finalize, what we are doing right now, pandemic and everything has been affecting us in several ways. And so some aspects of our work has been reduced, but other aspects of our work is now in more demand. We are going to more places, more remote areas. We're incorporating a remote assistance through augmented reality, mixed reality, and artificial intelligence. We're doing now a project about pain distraction and stress relief for teenager cancer patients using VR. And a project with the military forces about human rights respect, training on VR. And we are bringing the Mission School Peace project to other countries throughout Latin America. And that would be from my side. Any question, happy to answer.
Thank you so much, Bruno. It's really great to hear about those future plans. And thank you to all three panelists for those brilliant talks, which were extremely complimentary. And it was really good to hear how you're approaching things, well, sometimes the same thing from different angles. So now we're going to turn to the questions that have been presented in advance or through the discussion. And thank you for responding to some of those already. I'd like to pick up first on quite a big theme that's coming through and 3 or 4 of the questions relating to assessment in this context. So Stuart Edwards asks, do you have any interesting examples of using immersive technology specifically for assessing skills acquisition, including linked to formal qualifications? Wendy Choi asks, I'm not expecting to answer all these, I'm grouping them together. Wendy Choi asks, what are some examples of immersive technology used for formative tasks and feedback in various subject areas? And Esther Hunt asks, specifically to SIM, so we might come to you first, what methods do you use to obtain feedback from students to ensure they're learning at a deep level? So all those 3 questions relate somewhat to the topic of assessment and education, which is clearly very important. So I'm going to come to you first, Sim, and then perhaps Thomas and Bruno, if you've got any reflections as well.
Thank you, Louis, and thank you everybody for those questions. Important question, yes, assessment is always not just a need, but a question that we asked ourselves the very first time we actually went in. And that's a question you want to ask before you start something. If I'm going to do something, if I'm going to have an intervention, how am I going to assess its success and actually attribute the success of the intervention to what I just did? Right? So we've You design the experiment appropriately, even if it's teaching a class, you design that experiment in such a way that there is a control group of subjects. And I think there was a follow-up question somewhere where I read, is there evidence to show that VR technology in classroom raises attainment or reduces the achievement gap, for example? So there are some examples that were shown by HTC when they did an internal study, where they took not the A graders and the B graders in the class, but the C and the D graders in the class, and exposed them to VR simulations of the content that was being taught in class, similar to the examples that Thomas showed earlier, that most of them traditionally usually get a handbook or a textbook or pamphlet to read, versus comparing them with VR outcomes. And you assess them on the same outcomes and give them this at the end of it, besides just a satisfaction survey. And you find that the B's and the D's and those who were failing, the C's and the D's, actually ended up getting a B in the class because of the intervention that was provided to them. And so you can follow up with surveys where you ask them, tell me more about this, with open-ended questions and with multiple choice questions, something I answered for somebody else earlier, is you get the feedback that tells you that they actually appreciated seeing the things in action rather than being told how it works. And that's what made the difference for the learning and conceptualization of said concept. And it helps reduce those achievement gaps. Now, novelty is something you have to study over the period of time to actually say whether it's novel or not. But at least for the first couple sessions or even over a year of exposure to this, students tend to like it more. There was a secondary specific thing that I took notes on, was assessing skill acquisition for formal qualifications. That's the best part. I think Bruno and Thomas will also tell you that their presentations were based around formal qualifications of people being trained and tested in environments where they're already working. Other examples include in San Diego, for example, we have emergency medicine training for nurses and physical therapy students, where I have personally, in my cardiorespiratory class that I teach in fall, said the following words: it's okay for that patient to die in a virtual environment, because you do not want that to happen in a real environment. So it'd rather be a simulation. The beauty of VR is that in a simulation, you learn, you see the signs, because you will not see those high risk, low frequency occurrences that happen in a hospital. And when you're in a stress situation and there is a code card that happens, how do you deal with that when it's your first time on that team, right? So if we train our nurses and therapists who are going to be in the ICUs early on during their studies in college, and they're better prepared when they go into their clinics, and the information translates better. So there is one example. Other examples, interesting you asked. So from a personal love affair with race cars and race car drivers, I've been training race car drivers, a couple, now not amateur anymore, they've turned professional, both of them, 18-year-old race car drivers who turned pro, and they are trained in my lab on racing simulators with heart rate monitors and EEG monitors, brain monitors. And I helped them understand how they were holding their breath, or they were not breathing through a turn at 90 miles per hour and may have made the wrong decision going through the curb. So there are very ways. Again, I will beat this drum over and over again. You're limited by imagination. Tell me what you want, and we'll figure a way out.
Thanks, Sim. Thomas, Bruno, any reflections to share on the role of assessment?
Yeah, I mean, in addition to the excellent points Sim already made, I just wanted to offer maybe two additional thoughts on this topic. One is that I think, at least in experiments, I think it's very difficult sometimes to document all the potential, but also all the challenges that come up with virtual reality-based training. And that is because we have to control so many things. Yet in virtual reality, you can actually do things that are very difficult to do in reality. And let me give you two examples. One is, if you have learners with different capabilities, in virtual reality, it's very easy for that learner to repeat that learning experience almost as many times as they like. Whereas in the real classroom, that of course is very difficult. Also, and that is something I'm working on, but also other people are working on, is of course the possibility to create adaptive learning environments. So we can actually diagnose kind of what are some of the challenges learners have, and then individualize some of the learning experiences for that particular learner. Again, that is something that is very difficult, if not impossible, to do in a classroom experience. And so these are two of the certain advantages I think I see for virtual reality. On the flip side, of course, there are also limitations still. So, for example, it's very difficult still to have long virtual reality-based experiences. So it's very difficult right now to imagine someone sitting in a classroom for 8 hours immersed in a virtual headset. There are other limitations that are more of technical nature, but I think on these, I'm relatively optimistic that these will be sorted out at some point in the future. I'll leave it there and pass on to Bruno for any other thoughts.
Yes, thank you. I completely agree with Simon and Thomas. What we do is really to define what is the success, what is the measure of success, how do we achieve our goal. And for that, sometimes we want to train people to do their jobs faster. Sometimes we want to train the people to do their jobs better. So it really depends what we want to measure. And as Thomas was mentioning, the repetition is a very helpful thing in virtual reality. So we worked with an oil company, and we created, I was saying the example that you mentioned, we created a crane for oil rigs. And so the company had one crane somewhere in the country, and only one person could be trained, you know, and it was very expensive. So creating this virtual reality, the assessment that you want to do of the skills, it is very clear at the beginning, because at least for the crane operators, there is a really well studied set of skills and things and operations that you have to do. So we can measure that in virtual reality. We can see all the movements, how many movements, how many things and time the person did for carrying certain operations, and then from that we model, and then we can assess the skills. So it really depends how we define success.
Thanks all for those really insightful points. Just moving to another topic that seemed to come up in the questions is around equity. So we hear a lot about the idea of the digital divide, and obviously VR headsets are quite expensive, although I suppose these days with the Google Cardboard and equivalent solutions. But we've got a question from Nick Sample. Given the cost involved and pace of change in technology, how should government, schools and teachers decide what technology to make available at scale and equitably to learners? And Hilda Mwangi also has a question around the adoption of immersive technologies as a means to equalise access to education. So I'm not sure if any of you have any thoughts on the practicalities, perhaps, of implementing these tools. Or Thomas, I see your hand's gone up. I'll come to you.
Yeah, well, maybe the first point I just want to throw into the round, and I'm keen to hear Bruno's and Sim's thoughts, because I think you have, very interesting and different contexts to also, reflect on. But from my perspective, the hardware is actually not the problem. And a lot of people, I think, who are getting into virtual reality, they initially think kind of hardware is kind of the really expensive bit here. But in reality, I think that's rarely the case. I think the expensive bit still, from my point of view, is actually the software side of things. And how do you create kind of the virtual environments that are then used for these meaningful immersive experiences? And so if you look at the costs and where companies, for example, have to spend a lot of money on, it's not the hardware necessarily, it's the cost of creating and maintaining some of these environments. And so I think that's where I see a lot of optimization potential. And that's something that certainly has to come down to make it much more widely available. But just to give one example, I think that is encouraging. There are a lot of companies that are already working on self-authoring tools. So making it much, much easier for people to self-create some of the virtual environments they're interested in. And I think these tools will only get better as time passes on.
Well, adding to that, what we've seen in the marketplace is that with the COVID pandemic, the people were reticent of having a VR headset and then sharing it to the next person and sharing it to the next person. As Thomas mentioned, the cost hasn't been the real issue, but we saw a shift to augmented reality because mobile phones have a lot of technology already embedded in with augmented reality, and that makes things cheaper. So for certain use cases, the use of augmented reality is increasing for many things, and especially from the pandemic.
I agree with what Bruno just said, especially for mass scaling, reducing achievement gaps, or for implementation in areas where you might not be able to support the infrastructure, where you can't support 30, 40, 50, or 100 headsets in a classroom somewhere in a primitive rural area. Augmented reality allows you to do that because everybody has a cell phone, and the cell phones are so powerful right now that I could be on this meeting plugged in through my cell phone onto a external screen. So from a implementation standpoint, like Thomas said, it's not the hardware that's the issue, it's the software, and it's the creation of the simulation and bringing people who will actually program the software and maintain the software. Because every 2 days you get an update, and then you got to restart your computer or laptop or Mac or whatever it is, and every update messes with the previous gen of the program you made, which needs to be updated as well. So hardware stays the same for 3, 4, 5, 6 years, but software is where we are lacking. That's the need.
Well, thank you all for your reflections there. So moving on to the next topic, and I think Sim, one of your slides towards the end, touched on this, not the Liverpool badge. And Bruno, you mentioned the socio-emotional skills as well. And it relates to a question from Colin Price. Have you thought about using learning conversations or Viva exams? So just to broaden that question out ever so slightly, I mean, is there a risk with using immersive technologies that we risk perpetuating a solitary education as a solitary endeavor, kids with headsets on, not collaborating? Could any of you offer any thoughts about the role of collaboration in this context?
I agree. There is a fine line where you want to draw that you don't want to isolate the student. That's why for me, a learning experience is eyes open in my classroom, looking at me face to face talking. And if you want to integrate, then it's 1 or 2 users at a time. And that's how we have actually designed our classrooms, because you have to design the infrastructure surrounding the technology that you're going to use. So now we have these studios on campus called Learning Research Studios that we've designed in such a way that not every student is going to be in a headset at all times. There would be worst case scenario, 4 students at any given point of time out of a class of 30 who could be in that immersive scenario. That way, you go into breakout rooms. And we were doing that physical breakout already. So you change the way you're teaching that class, right? So you send them into a breakout room, everybody experiences it one by one, and then shares that experience, comes back and talks about what that experience was in a group discussion, in a Viva form, having a dialogue about it. So yes, Colin, that would be the way to integrate VR. But I was thinking about it from another thing, from another perspective, and that was, you can actually, and we've done this, there is a colleague at SUNY New York, at the State University of New York up there, who has done this for her art students, and she runs a virtual program. And especially with COVID, it got hit where students couldn't meet the 3 times a semester that they were coming to meet. So she ended up developing this, what is equivalent to a social workplace hangout that Facebook has. And she developed a similar classroom where her art students came and did a art demonstration in an art gallery, in a virtual art gallery, where everybody tuned in, put up their painting, uploaded their slide, and talked to the slide in a virtual environment. So it's useful for a situation like this, where you and I are talking from around the planet. But in a physical space, I wouldn't advise putting 30 headsets in the same space and then everybody being siloed to their own. The whole idea is to break the silo, not to make a silo. My 2 cents.
Thanks, Sim. Thomas, could I come to you, and then Bruno, just for your reflections on the role of collaboration?
So I think I can't speak for Sim and Bruno, but at least in my case, I get asked this question actually a lot. And the answer is, I wouldn't worry too much about it right now. So a lot of people think about the Matrix, and then all of a sudden everyone is super immersed in this. We don't live in the real world anymore, and everyone is just kind of completely immersed. I think we're far away from kind of this scenario. But what I will tell you is that I see a lot of positive and encouraging examples already. So for example, in an industrial context, what has certainly been very encouraging during the COVID-19 pandemic is remote collaboration and kind of remote maintenance and remote inspection being made possible, for example, by augmented reality solutions. So imagine some form of asset in an industrial context doesn't work anymore, but the expert cannot travel to that particular site. But through immersive technologies, primarily augmented reality, kind of that expert can remotely then collaborate with someone at that location to help solve the problem. So I think there's an interesting example of a collaboration opportunity that maybe wasn't that easily possible before. On the flip side, I think this whole idea of people strapping on augmented reality glasses or virtual reality glasses to collaborate in some form of virtual space, that's something that already exists and people are doing it. But so far, I think most of the experiences are actually quite disappointing. So I know at the beginning of the pandemic, a lot of my colleagues, they said, wow, this is fantastic. Now let's all use the HoloLens and the virtual reality glasses to do it. And we did it. And then after a few minutes, we said, actually, it's not that great. And it's kind of heavy and it doesn't work that well. It's super laggy. Let's forget about that. So I think we're still a couple of years away from that. But a lot of big players are working very, very hard on exactly that idea of kind of creating these collaborative environments.
Yeah, well, in my perspective, it is absolutely true that technology is not yet so mature for that. There is the possibility of connecting with people and gathering in a room in a virtual environment, and of course talking and so on. But seeing a factory or doing things in teams, it's possible. But the way at least we are doing the virtual reality and the skilling is for individual skills. So we need to practice, and the person practices alone or maybe with one person that is kind of teaching the other person, but mostly self applied. And in the other cases where we really foster collaboration is in these mixed environments where some things are taught by people or with a tablet or any other medium, and they speak to each other in a classroom or remote, and then they use the virtual reality for their individual skills. So that's I think where we are at the moment, and the technology will get there where there is no lag and we can be anywhere in the world, and with 5G possibly the possibilities will be more.
Thank you all. Thomas, I'm going to come just to you for this question, because you mentioned during your presentation about the need for longitudinal research, and you mentioned the important issue about novelty effects, which often we do see a lot with EdTech interventions. And this relates to a question that Maria Keckler posted in advance. How can qualitative researchers add value to this work? So you spoke about RCTs and the need for these randomized trials, but obviously there's a whole spectrum of other research approaches. So I was just wondering if you had any reflections on that, and how qualitative research or mixed methods research might usefully contribute to research in this area.
Well, I think this is a fantastic question. And I think the confession here is that a lot of engineers working on this problem are blissfully ignorant of kind of the whole educational, psychological, and other perspectives that are, of course, incredibly important in thinking about how can a meaningful learning, dare I say, educational experience actually being built. And so I think from my humble perspective, of course, I think the more this can be illustrated as to kind of what actually makes an educational experience, how do people learn, what are some of the things that need to be considered, what does a rich, meaningful learning or educational experience consist of? I think this is something that qualitative research, I think, can explore, inspire, and motivate engineers and then computer scientists to think more carefully about, and then maybe build this in some of their ideas. And in fact, some of these things might not be possible to engineer. So there might be elements that cannot be engineered, yet are very important. And again, it's the role of qualitative researchers then to show some of the limitations that exist and then make people aware kind of these are important things, but these are not possible right now maybe to research or to engineer.
Brill, thank you. And it's brilliant to have an engineer saying that it's not all just about randomized control trials on video. So that's good too. Sim, I'm going to come across to you now, because I think you touched on towards the end of your presentation about involving multiple senses. Well, number one, how can immersive technology engage the 5 senses beyond sight and sound? And number two, Pam Bernard, a colleague in the Faculty of Education, asks, what's the effect on VR on student creativity?
Effects of VR compared to AR. I saw that. I do not have the answer to that right now, because you would have to run an experiment VR versus AR to this thing. So I don't know yet. And I don't even have an educated guess to go with which one would be a better experience right now. Before that, remind me the question again, the other question, please, the first question.
Yeah. So what are examples of immersive technology, or what are your thoughts?
Oh, multisensory integration.
Exactly, yeah, beyond just sight and sound.
All right, so now Thomas is going to love me for this one, because I'm going to talk like an engineer, and I'm a reverse engineer. That's the degree I have. See, if you have a signal, you can translate it into anything you want. So if at a very basic level. So if you can write a simulation where it's raining, you can add physics to the rain and transfer it to haptic vibrators onto a vest. So that way is when you are in a virtual environment where you walk out of an elevator and it's raining, then you're able to feel the raindrops at least vibrating on your shoulder. You engage some senses over there. So haptics is one way of integrating that. Right now, there are haptics. You touch, feel some stuff, but you don't feel the force to go with it. Gravity doesn't act the same way in VR as it does outside. And that's the discordant senses that causes the motion sickness in the VR environments in the first place, when your vision doesn't match the vestibular and proprioceptive sense. But I've found a few hacks around it. For example, in VR environments, you can be Superman. You could be flying. You could just step into this thing and press the trigger on the VR on the VR remote, and you're flying. You point in that direction and you're flying. But when you stand and fly, you got to add context to it. When you stand and fly, you get sick because your head is shaking this way, whereas the perspective of the flight is horizontal, okay, lying down on your belly. So what we did is we took a gym ball, one of those large physio balls, lay down on it and Superman yourself and fly. And when you're flying in the direction that you're supposed to be flying in, correct the context of the y-axis, the person doesn't get sick as quickly. They do get sick, but they don't get sick as quickly. But now you put a fan in front of them that is controlled by a USB on the simulator, such that the harder I press the button, the faster I fly, the fan speed increases. Now it gives me the sense of wind on my face. It reduces the sickness. So same thing with the driving simulations that we do. We've got hydraulically controlled simulators. We've got 4 robotic actuators at the bottom of the seat, and we've got a vibrator under the seat that's connected to the bass boost. So it will not only give you engine feedback, but gearbox feedback, but terrain physics as well. So you start riding on a bumpy road and the simulator starts vibrating as if you're on a bumpy road. Integrate the senses, people stop falling sick. So, there are ways of engaging other senses beyond just the visual that we use right now. And even that, again, goes into the novelty. People love it when they see it, but then they start throwing up 3 minutes later. So how do we increase this thing is engage other senses into it.
Brilliant, thanks for that. We've got 3 minutes left, but there is a really important question that I want to put to you. I'm afraid I'm going to have to ask you to keep answers really brief. It's from Liam Peachman. And obviously, it's important to adopt a very critical stance towards EdTech, because often EdTech tools or technologies that have been proposed to sport education haven't lived up to the promise in actual practice. So Leon asks, what do you think are the biggest challenges to a widespread adoption of immersive technology today? What do you think are the biggest challenges to a widespread adoption of immersive technology? And I'll come to you, Bruno, and then Sim and Thomas, if you have any other thoughts.
Well, it's the pervasiveness that is lacking because we're seeing we have already cheap devices, that the Oculus Quest and so on, that could be in every home. I think we are at a moment like when the internet was in 1996. That's where we are at the moment. We have the technology. It's not so great, but it's really good. But it's not as great as it could be. It's not like Ready Player One. So it will get there, and the pace of it will go faster from now on. And I really believe that for the next 10 years we're going to see a revolution on this.
And Sim, any final thoughts about this challenge?
Yes, thank you. I agree with what Bruno said, and I'd like to add to that a couple things. One is be clear about why and how you want to use the technology. What is the need? Because there is no one right answer, and you can't have a cookie cutter approach to it. Okay, so you can't say, I want to VR, now tell me how to. No, tell me what you want. What's the outcome that you're looking for, so that we can approach it in a systematic way. That way, we can use the right tools for the right thing. That's at the basic grassroots level. But you're going to zoom out, look back up. For mass scaling of any of this, you need visionary leadership that supports it and provides for the infrastructure and provides funding to make this access happen. Otherwise, it's not going to happen. You and me sitting in our own caves and can be happy for the rest of our lives under a rock. But unless there is leadership that supports it, for example, in an academic institution, we had directors of IT and the Vice Chancellor's Office and Academic Technology Services that believed in the vision, even if the thought was, let's see how long this lasts. Even if it's a fad, let's see how far it goes. Yeah. So you need support above you. You need hierarchical support for that.
Brilliant. Thank you, Sim. And given the time, I think we should draw things to a close there. So just to thank all our speakers again for your excellent talks and really stimulating discussion, and apologies to the people on the call who we didn't quite get around to answering your questions. And just a final plug about the future DEFI events. We've got a number of these events coming up. Do check out the website and do follow us on Twitter and do get involved. So yeah, just to say thanks very much and take care.